Hi, I'm Larry Puckett, the DCC guy. Today I've got two things to cover with you. First of all, we're going to look at the combination of Sugar Cube speakers and 2-watt decoders from Soundtrax. And then we're going to take a look at the brand new PSXX circuit breaker setup from DCC Specialties. So stick around. But before we go on, I want to ask you to support the channel by subscribing. And it won't cost you a penny. All you have to do is hit that little red subscribe button. And when the little bell comes up, click on it and click all. Thanks now. Let's go ahead and start with the feedback, because that brings up the first topic that I want to discuss with you, and that's about using Sugar Cube speakers with Soundtrax decoders that have 2-watt amplifiers on them. And this came about as a result of a comment that I got from one of the viewers who was having troubles with some of his decoders losing their sound output. And he had talked to Soundtrax tech support, and they told him it was because he was using Sugar Cube speakers. So I got on the phone with George Bogatok at Soundtrax, and we spoke for about an hour about this. And so what I have to show you and tell you, I think will help you clear up the problem in the future. So let's go ahead. I'm going to zoom in so I can give you a close-up of all of this. Okay, so what I have here, as I said, is your standard Sugar Cube speaker and enclosure and a Soundtrax Economy plug-and-play decoder. And this decoder can put out 2 watts of power for the sound. Now, most decoders are rated at 1 watt, so this can put out twice as much. It's much, much more powerful. They also have some other decoders in their line that put out 2 watts. So be aware of that when you purchase a decoder. Find out whether or not it's a 1-watt output or a 2-watt output. And that's very important. It's going to give you a lot more sound, but you have to be careful about how you go about doing that. Now, the problem comes when you use only one of these Sugar Cube speakers, because these are rated at 0.7 watts nominal and 1 watt max. So these are rated at less than half of what this decoder can put out. And that creates problems potentially both for the speaker and the decoder. Now, I know that in the past, I have always mentioned that I always cut my master volume in half. And what that does is it reduces the voltage going out to the speaker by half. But that also has very important implications for the wattage, because it cuts the wattage down to about 0.56 watts. And that's about a quarter of what the full wattage would be. Now, I always thought that it was more important to protect the speaker than to protect the sound chip itself. However, it also has implications for the sound chip, the sound amplifier here. Because if you overdrive this by putting out 2 watts and you've only got about 0.7 to 1 watt here, it can heat up your amplifier and smoke it. And that's something you don't want to do. Now, the solution that the folks at Soundtrax recommend is to do one of two things. Either buy a 2-watt speaker and match the 2-watt speaker with the 2-watt amplifier on the decoder. And that's going to give you the best resolution, because then you're not going to blow either the speaker or the decoder itself. The other thing you can do is to use 2 of these small Sugar Cube speakers rated at 0.7 watts. Hook these up in series, and that'll give you about 1.4 watts. And that will be sufficient to protect both the decoder and your speakers. Now, the other solution that I have been using is, as I said, to first cut the master volume in half from the very beginning. And that will protect it. Now, the problem that Soundtrax sees with doing this is that users will then go to a train show somewhere and crank up the sound so that they'll be able to hear their locomotive over all of the background noise. Or at some time in the future, they might do a decoder reset for some reason and then forget to reset the master volume to that much lower level. And that's that's a very important consideration, because either way you can end up blowing your sound decoder again if you don't have it matched watt for watt, okay? So the best resolution is either use a speaker rated at 2 watts or use 2 of the Sugar Cube speakers in series to give you something rated at about 1.5 watts. And they're not so concerned about that solution because the default setting on these decoders for the master volume, I believe, is 192, which is about 3/4 of the master volume output total. So that will be set at about 1.4 watts, which is somewhere around 3/4 of the wattage for the speakers, and also about 3/4 of the wattage for the output on the decoder itself. So those are a couple of things you've got to be concerned about. Don't be cavalier about this and think it's an empty warning or some marketing thing. You need to be able to protect your speakers, but you need, more importantly, to protect the amplifier on the decoder board. Now, on the 1 watt decoders, and just about all the other decoders made by other companies that I'm aware of, are maxed out at 1 watt. They do not have 2 watt amplifiers on them. Maybe some of the larger some of the larger amperage decoders will, but I'm not that familiar with those. But for the most part, for HO and N-Scale, you're going to be dealing with 1 watt audio amplifiers on the boards. So cutting these down, I mean, even just running these at 0.7 watts is not going to overtax that amplifier circuit and overheat it and cause it to burn out. But even so, I still cut the volume in half because, in my opinion, they're just too loud otherwise anyway. And by cutting it in half, cutting that output down on that CV for master volume down to about 100 or so, maybe in that 100 to 128 range, that will protect both your decoder and your Sugar Cube speakers, no matter whether it's a 1 watt or a 2 watt amplifier on that board. So keep that in mind when you're installing decoders or selecting decoders and speakers for your next installation, particularly if you're using some of these 2 watt rated decoders from Soundtrax. Okay, the next thing I want to take a look at is the brand new PSXX circuit breaker from DCC Specialties. Now, I've been using the PSX circuit board from DCC Specialties for about 5 years, and I absolutely love it. It does a great job of distributing the power from my 8 amp command station booster combination, and it protects the whole layout from short circuits, particularly my booster, because that's mainly what these things do. They mainly protect your booster, and secondarily they will protect your decoders and your locomotives from these short circuit situations. Okay, so what's the big difference between the PSX and the PSXX version of these? Well, for one thing, you'll find that you can only get these in 1, 2, and 3 circuit combinations. The PSX used to be available as a PSX4 with 4 circuits on one large board. However, this one is just a little bit larger. I think it comes in at about 2 5/8 by 5 inches or something like that. But it's just large enough so that only 3 of them will fit on one of these green boards that they used for making up the circuits. So they can't make anything bigger than a PSXX3. So you can get these in 1, 2, or 3 circuit combinations. And if you need a 4th one, you can add an individual circuit board. And the interesting thing about these is, even though they're created as one board, they are 2 independent boards. And so they have a scribe line right here on both sides of the circuit board, and you can actually break these in half if you wanted to later on split them up and use them elsewhere. Now, the other thing about these is they've greatly simplified the programming on them because they've taken some features out and done some other magic things with the microprocessors on these solid-state boards. And these are all solid-state. There are no relays in here. These things will trip quite quickly for you, and you don't have to worry about the delays that come with using relay-based circuit breakers. So what's the big difference? Well, one thing that you'll find right off is they have set them up now so that you can set the trip current, and that's the way they work. They have a current that they will work up to, and then they will trip. And that allows you to set up the blocks on your layout and designate the amount of current that each block will be able to pull from your booster. So the way that these work is they're basically like the circuit breakers that protect the various circuits in your house, in your electrical panel box. And you can change the ratings, where those are rated at maybe 15 amps and 20 amps and 30 amps. These can be set at 1 amp, 2 amp, 3 amps, all the way up to 10 amps. And it can be done two different ways. So right here with this jumper here on this side of the board, you have the option of using soldered connections, soldered wires between the various little solder contacts here. And you can combine them together to create a 1 amp trip current, a 2 amp, a 3 amp, or a 4 amp trip current. So you can go up to 4 amps by just soldering various combinations of these contacts together here on this jumper. After that, if you want to go up to 10 amps, you can reprogram the board so that you can go with individual values of 1, 2, 3, 4, all the way up to 10. So that gives you a lot of capability in order to be able to set different values for your yards and your sections of your layout, and basically to be able to protect your boosters and your command station from shutting down due to shorts that occur in those segments, those blocks. So that's what these are really great for, to basically isolate the various blocks on your model railroad from one another and from your command station. So that on the Piedmont Southern, the way I do it is, I would have one block protected by one of these circuit breakers. That might be my main yard at Monroe. And I might have that set with a trip current of 3 amps, because there'll be a lot of locomotives running in that yard. And then at another section of the layout, say at Red Hill or at Amherst, where there's only going to be one train at a time probably, I would have another circuit breaker protecting that block, but it might be set at only 2 amps or 1 amp, depending on how much traffic I expect at any one time in that. And I explained all this in a video I did on power management, and I'll put a link to that above me here and also at the end of the video, so that you can go back and review the concept of power management and how to balance the load on your layout and on your command stations and boosters by using these circuit breakers and various combinations of the amperages that they are able to operate and trip at. Now, one of the nice things that they did change about these PSXX is you no longer have to set a discrete trip speed, because in the past you could change that value. You could go in and change a CV and program it so that it had different speeds at which it would trip. And that was very useful because a frog juicer, for example, can trip very, very quickly, somewhere on the order of 200 to 300 microseconds. And that was about the same speed as the default setting on the PSX board. And that created problems because sometimes the frog juicer would trip first and other times it wouldn't. And in that case, it would shut this guy down. And then there's also situations where if this is not set faster than your command station, then your command station or booster might shut down. What they've done is they've changed the whole algorithm and approach to how that is handled within the circuitry on this board, and it can take care of any situation without having to go to setting up discrete timing. So that makes it a lot more simple to use in that respect. Now, the thing that they have done that really adds a lot of operational capabilities to these units is the ability to use this for block detection. Now, the PSX boards did have block detection built in, but these take it to another level. They have a lot of other options and ways to use block detection, and you can use block detection two different ways. You can use it based on the current consumption in the block. So once a locomotive or train comes into the block and the board senses that that locomotive is there based on the current increase that is passing through it, then you can have it do certain things. It can light up an LED on your control panel telling you that that block is now occupied. They also have it set up so that you can use photocells or photodetectors. And you can put a photodetector in a block or somewhere on a track, and when it is covered, then an LED will light up and indicate that that track or that block is occupied. And then as soon as the train moves through and off of that, outside of the block or off of that photocell, then the LED will go out or another will come on. So that's one thing you can do. Another way you can use this is you can use one of these to power a staging yard. And then when the locomotive comes into the staging yard, you could have a photocell at the end of the staging track, and it could cut the power off to that yard. And then you can turn the power back on later when you want to move the trains out again. So that's another neat feature that these can be used for. Now, as I said, there are various ways to use the detection here on the board, and there are various outputs. And you can set these up so that various LEDs will come on or go off depending on the status of the board itself. So it can tell you when a block is shorted, it can tell you when a block is occupied, it can tell you when a block is unoccupied. So there's a lot of features that are built into this. You can also route the output on some of these jumpers through interfaces to your command station and use that to report back to programs like Decoder Pro and the like, and use that as an indicator to tell you the status of the block itself and whether or not it's occupied, whether there's a train in the block, whatever. So these can function as a block occupancy detection board and also as a circuit breaker to protect your command stations and your boosters from those short circuits that are constantly happening when people run through switches that are closed against them. Now, wiring these hasn't changed a bit. It's still very simple. Or these screw terminals here are the power input. So I would connect these two, this red and this green wire here, coming in to positions 1 and 2 on the screw terminal. That is the DCC power in. And then I'm just going to daisy chain the output here to the next one. So I've got the red going out and into terminal 1 here. I've got the green going out and into terminal 2 here. So I can take the power from one booster or command station booster combination, take it into the board, go out to the next one, and keep doing that for as many boards as I want to operate off of a single booster or command station. So that allows me to very conveniently set up these boards right with my command station. And I showed how to do that in a video that I did on installing DCC on your layout, and I'll put a link again right above me to that video so you can go back and see how I actually wired in and installed the PSXX in that case. Now, once you've installed these, you've got power coming in here and daisy chain to the next one and to the next one and so on. And then over on this side, we have the output terminals. And these feed power on out to your DCC track or power buses. So you could have a power bus for block 1, block 2, block 3, block 4, however many of these circuit breakers you have in line. So that in effect allows you to run, as I said, 2 blocks, 3 blocks, 4 blocks, however many blocks you want, and have power to off of the input from one booster. I run half of my layout, half of the Piedmont Southern, using 4 of the PSXs with one 8 amp command station booster, a DCS 240 rated at 8 amps. And that allows me to distribute the power using the power management concept to all of those blocks independently, and to protect the command station from short so that it doesn't ever shut down. Now, another neat feature that they have included as part of this block detection magic that they've added, one of the things that you could have if you've got a lot of frog juicers and accessory decoders and various other devices that might consume a certain small amount of current on your layout, is that you can get a false detect based on current detection methods. So, how do you get around that? How do you avoid that? Well, they have an auto calibration technique that allows you to set the board up so that when you turn it on, it will automatically monitor the power consumption in an empty block. And then from that point on, it will save that value of power that is being consumed within that block. And then in the future, you can use that to basically tell the circuit board to ignore that level of power consumption, and therefore you won't get those false detects. So that's a really neat feature that you can use to be able to calibrate the board function to your individual model railroad. So if you've got a yard full of frog juicers, or you're running some other things off of your track power, and that's consuming power, and it might look like a locomotive's in there, then the board can automatically calibrate itself for that level of power consumption within that block and ignore it in the future, so that you'll only get detects when a train actually enters that particular block. So that's a really neat feature that I thought that Larry Maier added to all of this. And by the way, these were designed again by Larry Maier, the electronics engineer at DCC Specialties, who has designed all the other great, neat products from that company. Each one of these boards can be given 3 accessory decoder addresses, and that's done the same way you do with other accessory decoders. And then the first address given to the board is used to actually turn the board itself on and off. So you could use your handheld throttle to turn the power on and off to a given block. Now, the second address is used to turn the photocell activity on and off. So you can use that way as well. So there's a couple of nice little features there. And of course, you can create your own addresses, and they go through it in the manual about how to do that. So at this point, I'm going to call it an end for the introduction to the PSXX circuit board. And in the next video that I do on this, and I'm not sure it's going to be next week because I've got something else coming I'll mention in a moment. But what we will do is I will connect this up to the NCE SB5 system that I installed on the modules, and we'll set it up. We will go ahead, go through the programming steps for the board, set up the addresses, set up the various trip currents, and give it a test drive on the module using the NCE SB5 system. The other thing I have coming up for you is I just got an email yesterday from the folks at TCS, and the new UWT-50 Wi-Fi throttle is available. They have shipped me mine, so hopefully in a couple of days it will be here, and we can take a look at that next week. So that's it for today's video. Keep in mind my warnings about using those Sugar Cube speakers individually with the 2-watt amplifier type decoders. Also, if you're interested in finding out more about these PSXX boards, go to the Tony's Trains website, tonystrains.com, and do a search for PSXX. And then on that page that comes up, click on the instruction manual link and download a copy of the instruction manual and take a look at it and familiarize yourself with it. And then in an upcoming video, I'll go ahead and we'll run through setting it up on the layout, on the module, and run it through its steps. Other than that, that's it for this week, so have a great weekend, and we'll see you here next week with another video from the DCC Guide. Bye now.